this video and in the next video I'll be breaking down the slides, and this is for the pro and in this video I'll be discussing the probability distributions. So I'll directly so in this slide particularly we will be discussing the distribution. We will start from the random variable and then we will discuss the distribution, how what's the relationship between the distribution and random variable. And within the umbrella of distribution we have two major types, what they known as a continuous distributions and the discrete distributions. And further, we covered one distribution in each type. We did one continuous distribution, which is normal distribution, and the other one was the binomial, which is discrete in nature. So I'll start off by explaining the random variable, like what is a random variable, right? Because this is the base for everything. Um, for everything, I mean, from random variable, we derive the distributions, and from the nature of the random variable, we classify the distribution between the two types, which is continuous and the discrete. So the random variable is that any experiment, which is although we know the outcomes, maybe in some cases we don't even know the outcomes, the range of the outcomes. So for example, if you throw a dice, while throwing it, we at least know that it's going to be one of the six options we have on the dice, one of the six numbers that we have on the dice, right? So we know we know the range of the events that can occur, what we call as space. Yeah, we call it as an event space or space, like all possible outcomes. And then based on the number of outcomes, we try to assign the probabilities to each outcome. But that's something we will discuss in later video, or maybe in the last part of this video. But you understand the nature of the random variable. So throwing a dice is a random variable. It can take any number out of six, and six is the six different numbers is your sample space, or it's just a space, the possible outcomes. You toss a coin, you have two possible outcomes. It's going to be either tail or head, right? So these are very like comprehend. Your mind can comprehend these options, but there are certain, although like there are a huge number of random variables, which are like even not comprehensible by the human brain. So there exist such random variables as well, or maybe the range of the the range of that certain random variable can vary into a huge sort of an a range. So for example, in stock, the stock prices, right? The stock prices can fluctuate in either direction. They can go down, they can go up. So those are all like you can never say what could be the range of the stock return. They can even collapse, right? You can go bankrupt. So this is the nature of the random variable. But then from the random variable, there comes the idea of the distribution. So what we really mean by the distribution. So what happens is, if you take the experiment, and for the simplicity, I'm just taking the experiment of the dice, right? I am throwing the dice, and I probably going to throw dice 100 times. I'll do it for 100 times. I'll throw the dice 100 times, right? And what happens is, like, for every throw, I'll be getting a certain number, a certain outcome out of those six possible outcomes, right? So I'll have 100 outcomes, right? From first trial up till 100 trials, I'll have a certain number of the dice, maybe two, six, four, six, and so on, right? For the 100 trials. Now, when you record these 100 trials, you will see a certain pattern. You will see, so these outcomes will try to follow a certain distribution. So in this case, it's going to follow some sort of a discrete distribution. And it's discrete because you have like very solid points. Like it can be 1, 2, 3, 4, 5, 6. It can never be, it's never going to be 2.5, 2.75, or anything between those numbers. So these are very discrete. Like discrete means one particular number, like step by step. You have a discrete point. It's not continuous. Like there's nothing between one and two. You have no option between one and two. If you're going to jump, you're going to jump from one directly to two, or maybe three, four, five, or six. So there is no range of other numbers between that. So when you record all of these 100, record the output of all of those 100 trials, those 100 outputs are going to follow a certain distribution. And then you will try to name that distributions. But we are not going into that discussion. Just understand the difference between the discrete distribution and the continuous distribution. And in the I'm repeating it again. In the discrete distribution, you have a very certain solid point, right? In the coin toss example, you have either head or tail, right? There is nothing between head and tail. But when you take an example of stock prices, right, or maybe time, like if you put a like if there's going to be maybe a marathon or a sprint, and there's 100 students who have joined the competition, and you have like you're recording the time for each student, for each 100 student, and you put 100 stopwatches for each student. Now you're going to record the time period for each student. So the time period to complete that marathon for each student will be ranging between minutes, right? Now these this can be continuous. Like maybe two students can complete in the same time frame, or like it will be a difference of a few seconds or milliseconds. So you have a continuous kind of a thing. And again, if you start, you know, recording the temperature of different bodies, it's going to take values in points, right? If you start recording the returns on your stocks, it's going to take it's going to take values maybe in negative or maybe in positive. Like you have a certain stock, you have an anglo stock, the first day it gone up, the second day it gone down. So you have a positive record in the first day and then the negative record in the second day. So it has a vast kind of a range, and it continues, and it's a like huge kind of a range, and it can take values even between those ranges, right? So that's the difference between the continuous and the discrete distribution. So if you have 100 different stocks in your portfolio, and you record the returns of those 100 stocks of different companies for like maybe 30 days, right? And those stocks are going to follow a certain distribution, and that certain distribution is going to be continuous. It's not going to be discrete. So that's the difference between the discrete and the continuous distributions. So Sir Asim has explained us like we covered only two distributions. Like we have now covered two types of categories of distributions, but in those distribution we have covered one for each. So binomial is discrete distribution, and the normal is the continuous distribution. Why it's not? Okay, so I'm just explaining and giving you the example of the binomial. So let's solve the binomial first. So this binomial distribution is your discrete distribution. We have many other discrete distributions. We have Poisson, we have Bernoulli is the most basic discrete distribution. Then we have binomial, Poisson, logistic. So these are all discrete distributions, right? And for just like for the sake of sticking to the point, we are just going to discuss the binomial distribution. And in the binomial distribution, you have few things that you need to keep in mind. That the binomial distribution is going to be for the binary outcome. It's going to there's only going to be two options. Like the outcome of that certain experiment, whatever the experiment you're going to play, or whatever the random variable. So when your random variable can only take two values, right? In binomial distribution, your random variable can take only two values, first and second, like only two values. So, for example, a coin toss is the most classical example. In this case, you have head and tail options. So stock prices, but like stock prices is not a discrete distribution. Maybe take some other distribution. Um, Maybe some other example. For example, yeah, the if you just have to pass and fail the exam, right? So for the exam, you can just pass or fail. Like there's nothing in between. You can either going to pass the exam or you're going to fail the exam. And we have many other examples similar to this. So for the binomial, so the binomial distribution, the random variable can only take two values, and in the binomial, another assumption is that the two outcomes are independent of each other. So the happening of H has nothing to do with the happening of tail, right? So these two outcomes, so these two events of your random variable or your experiment are completely independent. This is very important for this because I think this, if sir is going to take an exam or maybe giving a possible question out of this slide, so this can be because I remember a few of the questions were based on the assumption of the binomial distribution that it takes in that it puts in place. So independence of the outcomes was one of them. So you have two outcomes. Both outcomes are completely independent from each other. So the happening of head is has nothing to do with the happening of tail. And the other one was you will have a parameter of interest. Like you will be only interested in one of those outcomes. Like you're maybe like we take this example in a way that we are just interested in one of the outcomes and not both. So you may be just interested in the happening of H and not T, right? It's like one and zero. So you're just interested in one and not zero. So you have a certain parameter of interest, and it's important because the event that you are interested in or your context is built around a certain event, which is maybe let's stick to the head. So in this case we have a head is our parameter of interest. So I am only interested in knowing the probability of h my head, because when head turns out I'm going to win the game. So I'll assign p to that. So p is the probability of my of the outcome that I am interested in, or maybe the outcome that the probability of the outcome that I'll win. So if I'm in a match, I'm going to win or lose. So the probability will be for me to win, right? And I'll assign Q to the other outcome, which in which I'm not interested, or maybe I'm going to lose in that case. And the rule of the probability is that the range of the probability is going to be between 0 and 1. And if you have two outcomes which are independent of each other, so that means the probability of each outcome, and if you add them up, it's always going to be equals to 1. So if P was the probability of my winning and Q was the probability of my losing, if I add them up, they're going to be equals to 1, right? So this is the general rule of the probability. So for example, if the probability of the head is 0.5, then the probability of the tail is also 0.5, because the if you add them up, it must be equals to 1. So if the question is like, maybe this question can be like, if sir has given you the probability of you losing. So for example, if Q is given and Q is 0.4, then you can determine the value of the P, because in that case, the value of P will be 1 minus 0.4 and it's 0.6. So this is how you can really figure out the probability. So if one is given, the other one, you can really find it out. And then the next important thing, like you understood the P, you understood the Q, and you understood the one assumption that's been set in place. And the other thing in the binomial distribution is the number of trials. That's really important. So we're not going to try it for once, because For the binary outcome, if you just play the game only for one time, then it doesn't really follow the binomial distribution. For binomial distribution, you have to play the game for many trials. And that's why we call it n trials. Because if n is just equals to 1, it then becomes a Bernoulli distribution and will not be considered as a binomial distribution. So that's just a one thing that like extra in this. So if so you really need n some solid value of n other than 1. It cannot take, of course, negative or zero value. Then the number of trials are going to be 1 or greater than 1. So yeah, that's about the binomial distribution and the formula. So now if you if you need to figure out the distribution, so we have some question based on that. The formula for the binomial distribution is n trial x p to the raised power x q n minus x. So that's the formula for the binomial distribution. I'll give you an example, like what's n of what this term really means. This one, because that's the only extra you will see in the in the formula of the binomial distribution, because that's pretty simple. Like you already know about the p, you already know about the q, but what's n and x? N is your number of trials, as I said before, and x is going to be the favorable outcomes, the number of the favorable outcomes, right? So, for example, if you ran an experiment 3 times, right? And the head shows up 2 times. So your head, so your x is the parameter of interest. So head was something that you were interested in. So the probability of x happening will be p, right? So because x is the event that you are interested in, and the probability of the event that you are interested is always denoted by p, right? So X in this case was head, and P for, I'm just assuming that the P is zero point 0.6 in this case, right? And total number of trials were 3, and X shows up for 2 times. So you can solve the formula. So you have 3 combinations 2, P 0 0.6 to the raised power 2, Q is going to be 1 minus 0 0.6, which is 0 0.4, and N is 3 and minus 2. So you can solve for the binomial distribution. So here you can going to get the probability that if you throw the coin, if you toss the coin 3 times and you're going to get head like 2 times, you're going 2 times head out of 3 trials. So it will give you the probability of this event happening, right? I hope this makes sense. Like we're going to toss the coin 3 times, and we're interested to know the probability that out of 3 there will be 2 outcomes in which we will have head. And given the fact that the probability of head happening is zero point 0.6, so you can plug these values in this formula and calculate the probability here. So the probability, whatever the probability is going to be here, will be the probability of getting 2 heads out of 3 trials. And to solve this one, the combination, we have simple formula. Like you can also like calculate it from your calculator. It's a direct. I think the calculators are not allowed, and I assume that sir has also told that there won't be any need. So just in case, because sir has mentioned the formula for this, it's n upon x. I am going to write it for the general terms, n factorial, n minus x factorial, x factorial. So this is how we open it up. So for example, for this, it's going to be 3 factorial, n minus x, 3 minus 2, 1 factorial, x is 2 factorial. So this 1 factorial is 3 minus 2 factorial equals to 1 factorial. So 3 2 factorial, this is going to get cancelled out and you will left with 3. So 3, plugging in the values, 3 into 0.6 to the raised power 2, 1 minus 0.6, 0.4 to the raised power 1. So you can now solve this one and you will get the probability of 2 happening out of 3 trials, given the fact that the probability of P is 0.6. So this is what the Bernoulli distribution, this is how we work with the Bernoulli distribution. So moving forward with the continuous one, I already given you the idea of the continuous distributions. The stock prices is very classical example of that. The stock prices movements, it can go up and down, right? It can take negative values, positive values. It's going to up for one day, the down for next day. It can take values in points, like the first day gain was 10.6 and the next day gain is 10.7 maybe, and maybe down to 10.1. So that's the scenario with the stock prices. So this is very continuous in nature, and maybe if you start recording the temperature, the time, all of these are continuous variables. Like they are continuous in nature. They can take values in minutes, in hours, in seconds. So it's ongoing process, right? Like we have time even in milliseconds. So that's continuity in nature. That's where the continuity is playing. So the random variable, when so your random variable, if is taking if taking values between those ranges, so in that case the distribution for those kind of random variable is going to be continuous, and very classical and very simplest continuous distribution. The most famous one is the normal distribution, right? And the idea is like I'll just stick to the stock prices example, and I'm just going to take the example for the 10 days, right? I'm just recording the returns for my Engro shares for 30 days, not 10 days, 30 days. So I have a Engro share, and I'm going to record the stock prices for the next 30 days, right? I'll have 30 rows, one column of returns, and for each day, I'll have some value in points, negative, positive. So I'll have 30 such values. So these 30 values, when you start increasing your values, like they will, so that's a statistical property. So it really does happens when you record the returns, or you when you start recording the values of the random variable, b- at certain point they will start following a certain pattern, and that pattern is basically what you're calling as a distribution. So if you record the returns of on EngroShare for the next 30 days, they're going to follow a certain distribution, and that certain distribution is going to to be continuous in nature. And we're just assuming, it's not certain. I'm just assuming here that this, for the sake of the simplicity and for the sake of this particular class, I'm assuming that these numbers, which are continuous in nature, are going to follow the normal distribution. I have no clue unless I plot them. Unless you plot the returns, you're not going to know, like either they're exponential in nature, they're normal distributed, or what's the nature of the returns are. But generally, it's the majority of the random processes that are in nature are normally distributed. Now, let's discuss about, let's discuss the properties of the normal distribution. In normal distribution, what you will see is it will have a bell curve, a symmetry around what? It has it is symmetrical in nature, but in what sense? Like, is there, so when we say that it's symmetrical, then it's 100% true that it's going to be symmetrical around something. So in normal distribution, the the returns are going to be normally distribution or symmetrical around the mean. We will have a mean, and the data on the left of the mean and on the right of the mean will be equal. So if I had, so for just for the for the purpose of understanding, if I had 31 numbers, this number will be my mean, right? And I'll have 50 on the right of the mean and 50 on the left of the mean, right? So this is what the intuition of the normal distribution is. So the normal distribution, it is symmetrically distributed around the mean, right? So we will have a mean, we will have a certain value, and f- uh, from that certain value to the right, we will have the equal number of area or of the equal number of the entries, and on the left, we will have the equal number of the entries. But in the normal distribution, we do not discuss about the number, we discuss about the area, right? So what I mean is, when you draw a normal distribution curve, you say that this is our mean. Like, how, by the way, how do I mean that this point is a mean? The highest point at the curve, the highest point at the curve is referring towards your mean. Highest point on the curve, which is like, of course, this is the highest point on this curve, will referring towards the mean. So to the right of this mean and to the left of this mean, it will have an equal area. And just for the sake, like just remember that under this bell curve, the area is always going to be equals to one. The area under this curve is always going to be equals to one. And this area is also referred as a probability. So if I take an example of those 30 returns, right? For those 30 returns, I have plotted those 30 returns. So this curve is basically my returns of 30 days, and it's a continuous. These are very small data points for 30 points, for 30 returns. If I'm just referring to the example that I took before for the Angro returns, and uh, this line will be representing the probability for each data point. So I'll break it down further in the z-score. So the area, so just remember that the area of under this curve is going to be equals to zero, equals to one, right? So on the so because if because the area under the curve is equals to one, so and it's symmetrical. So to the right of this center, it's going to be 0.5, and to the left, it's going to be 0.5 as well. So the area on the both sides of that highest point is going to be equal. So 0.5 on the right and 0.5 on the left, right? So this is what it means. So let's just quickly look at this. I think that's again the binomial, that's based on the binomial. Just quickly look at this. Suppose that in Lahore, 35% of the households will donate money to a charitable organization and knocks on their door. If we knock on five random doors in Lahore, what is the chance that more than three households will donate? Okay, so now here first you need to understand what are you interested in? You're interested in to knowing the chance that more than three households will give a donation. So you're looking for the chance that people will make donation. And now look for the probability. Like this 35%, this is for is this the probability of giving the charity, or is this the probability of not giving the charity? This is the probability of donating the money to charitable organization, right? So this is your P, because this is what you're interested in, right? So your P is 0.35. And what is your N? So you're going five times. So your N is five. And then your N is five. And what will be your Q? The Q will be 0.35. And how are you going to like apply the binomial formula on this? What will be our x? What is the chance that more than three? So n x p to the raised power x q n minus x. So here in this case we have 5 3 p is 0.35. Sorry, yeah, exactly. The p is 3 minus, or 5 minus 3 is going to be 2. But look at the question. You need the probability that, so this formula is going to give you the probability that exactly three households will make donation. This formula is going to tell you this, the probability that the three out of five are going to make the donation. But you need to know the probability that above 3 will make the donation. So we'll simply just subtract the probability of 3 from 1. So this will give you the probability of the rest of the like for the rest of the people for the chances that the households the more than 3 households will make donations. So this is what you're interested in. So to know that, you will subtract the probability of exactly 3 making donations, but what you really interested is the greater than 3. So we'll simply subtract the probability of those 3 households that you will calculate in this manner, and you will just simply subtract the probability of those 3 from 1, and you will get the probability that that uh that more than 3 households will make donation, because this is what you were interested in. To find this, you will subtract the probability of exactly 3 making donations from 1, and you will get that the probability that more than 3 households will make donations. Because now here the associative rule is playing the game, like the probability of a plus b equals to 1. So if you have given a, you can find the probability of b by subtracting a from 1. You will get the probability of b. So that's the case here. Just remember this for the binomial, it's n. The mean is equals to is equals to np. The variance is npq, and the standard deviation is always the under root of the variance. So this is just true for the binomial, by the way. For any distribution in this course, or maybe in any other course, if you're going to learn about the mean and the variance are going to get determined by their own parameters. So in the binomial distribution, we have three main parameters, n, p, and q, right? So for the mean, we are going to multiply the n and p. For the variance, we are going to multiply the n, p, and q. And for the standard deviation, we are just going to take the under root of the variance. I have already explained this, the normal distribution. So just look at here what the slide is about. So you can see you have three distributions, the green one, the purple one, and the yellow one. All are symmetrical about certain mean. Like for example, if you take the example of the green one, here the mean is -4. Here the mean is -4. And like forget about the standard deviation. The mean is -4. It's now the green bell curve is symmetrical around -4. So by symmetrical, I mean the right side, the area under the right side, and the area under the left side of -4 is equal, right? Similarly, in the case of purple one, Now in purple, we have 0 as a mean. So in the stock returns, 0 can be a mean. Like after 30 days, this could be a case that you got a return of 0. Like in some days you're going to get you're going to get a raise, and in some days you're going to get a loss. So if you add them up, the negative values and the positive values maybe in the longer run are going to cancel out each other. And in that case, the sum of the stock returns will be 0, will become 0, and so the mean will be equals to 0. But although they are distributed around that mean symmetrically, so that is also following the normal distribution. And in the yellow one, they are symmetrically distributed among the mean of 3. So I just give you an intuition of this, like in what cases you will have mean equals to 0. Like if I start recording the ages of my classroom, the FMG and the supply chain, the average of the age is never going to be equals to 0, right? So it can never follow a standard norm. So by the way, we have two types of normal distribution. One is simple normal distribution. So it will be symmetrical, but it can take any mean. It can be symmetrical around any number. Any number means it can be symmetrical around -4, it can be symmetrical around 3, it can be symmetrical around -100, it can be symmetrical around 1000. The mean can take any value, and it will be the rest of the data will be symmetrically distributed across that mean. But in standard normal distribution, because I remember sir also explained that, in case of standard normal distribution, it's always going to be the case when the mean will equals to 0. When the mean equals to 0 and standard deviation equals to 1, in that case, the kind of distribution you will see is a standard normal distribution. It's just the case with the standard normal distribution. Like if you want to see a standard normal distribution, then the mean, we can also like denote it in this notation. So the random variable z is following a normal distribution, uh, small bracket 0 and 1. So this refers to the mean of 0 and standard deviation 1. So this is what it represents. So in your slides or anywhere in the notes, if you see this notation, this refers to the mean and this refers to the standard deviation. So it's just another other property of the normal distribution. It says that if so we have so you up until now you already understand in the normal distribution we will have the mean at the center and equal number of entries on the right and equal number of the data on the left. In in probability distribution we call it area, and this area is always going to be equals to 1. Like whenever you will be solving the questions and you will be dealing with the z-score and the probability, you will definitely going to get those kind of probability distribution in which the area under the curve is going to be equals to 1. And then for the different range of the z-score, I'll tell you what z-score is, but let's just look at this first. So 60, so if from the mean, this is your mean. If you go one step to the right and one step to the left, 68% of your data will be in this range. So so here what it really means is, if you just stick to that example of 30 days returns of Engro share, right? And maybe the mean of those returns were, let's just for example, the mean of those returns were 5, right? So the mean is 5, although, but for the 30 days we will have different. So for some day we will have 4.7. The other day we probably going to have 4.9, 5.1, 5.2, 3.9. For each day we will have different record. But 68% of those records will be one standard deviation from the five, right? And if you just broader that scale, and if you talk about for the for if you just go more and you take two steps to the right and two steps to the left, then it will cover the 95% of your data points. So out of 30, almost around 28 entries of those returns will be two standard deviation to the left of it and to the right of it, right? So this is what it means. So the 95% of your daily returns out of 30 will be under two standard deviation, right? Either it will be on the left of it or the right of it. And if you just even take more steps and you go three steps to the right and three steps to the left, you will be covering 99.7, almost 100% of those entries. So you will only left with some maybe outlier if there's a war, the if there's a war, maybe the company in some cases go bankrupt, and you will just realize that um, they were like kind of doing a sort of a fraud, and in that certain scenario you will see a certain outlier. Maybe the stock prices went from maybe 50 rupees to 1 or 2 rupees, so that could be considered as an outlier. And from the 99.7%, that outlier is going to get, is there's a chance to left out that outlier. Maybe that outlier is here or maybe here, and you cannot capture into your three steps to the right or left or two steps right. So that this is what it refers towards. Hmm. How do we look at these normal curves? I'll explain like how exactly we can look at these z tables. um oh, okay, so well, first look at first let's just understand the z to compare different normal. So, how many standard deviation in observation is from mean? This is what the z represents, literally. So, the formula of the z is x minus mu upon standard deviation. So, it will tell you that how many standard deviations an observation, which is x in this case, is from mean. So, this is what it represents, and literally the formula says that, right? You're subtracting the mean out of your observation, right? So for example, if my the mean of the stock price in the previous example we took 5, and for a certain day the return was 10, right? So my x for a certain day is 10, but my mean for those 30 days is 5, but for maybe the 29th day the return was 10. So how many standard deviation this 10 is from 5? Right? And the standard deviation is also given. The standard deviation maybe is 2. Right? So how can I find my z-score? If my standard deviation for the stock returns 2 is given and mean is also given, but for the 29th day the return was 10. So if I want to know what's the how many what will be the z-score in this case, so I can really calculate that. So the 10 minus 5 upon 2, so it's 2.5 standard deviation away from my mean. So this is what it represents. So the 10th, the return on the 29th day is 22.5 standard deviation away from the mean, right? So this is the z-score. So if I just go back here, this 10 will be in what range? Will it get covered in the 68% of the data? Not really, because in the 68% data, I'm just taking one step to the right and one step to the left. One step, I mean, for one standard deviation from the mean, right? But it will only get captured when I take three steps from the mean because it's 2.5. It's somewhere here. It's somewhere here. This 10 is somewhere here, right? So um, it's away from even the 95%. It's only you will only know about it when you cover the 99.7 percentage of the area under the curve, or you try to move three deviation from your mean. In that case, you will find the return of 10. So now so how can you really like look at the z-score? Now back to the table. This z table is basically gives you the probability, by the way. Like it tells you about the probability. Like if you want to know, it's not like it's just up until 2. So I don't really have access to 2.5. And let's just, for example, this was 7. This x was 7 minus 5.2. This will be 1, right? So if my z score was 1, right, 1.00, what will be the probability, right? What will be its probability of happening for this 7? For this 7, what will be my probability if I would have to answer the probability of my x equals to 7? The returns of the stock is 7, and I want to know its probability, and I have the z-score, which is 1, that I just calculated, and I have access to the z table. How I'm going to know about that probability? I'll come to the table. I have a 1 in this case, and this is my probability. Because now I am just looking at a 1.00. If it were 1 point maybe 0.01, then this will be my probability. If my z-score was 1 point maybe 0.7, then this will be my probability, right? So this is how you look at the tables. But again, there's one little caveat here. If you look at this, these probabilities are from mean to the z-score, right? And if I had to quote the probability for the 7, it should be from this point up until this point. So from 0 to z, it's 0.34113, but overall it would be 0.5 plus 0.3413. So that will be the total probability that the value is the z-score is less than 1.00 in this case. Or like if you extend the table and you take up and you start looking from the 2.5, then you will realize, or you will probably have a value for the 2.5 as well. I have a case scenario here. I just have another case scenario here. Like if I would have to know that the z score is greater than 1.64, if I want to know the probability of the values which are greater than the z score of 1.64, or in other ways, I want to know the returns who will be the returns that will be 1.64 standard deviation away from my mean. So by this, I if so now the question will be like will be put it in different ways. So it's really important for anyone to understand the language, right? And by this notation, what I mean is z score is my standard deviation away from mean. So if I'm saying that my z-score is 1.64 and I'm trying to find the probability of that, in other terms, I'm trying to find the returns whose values, the returns who are 1.64 standard deviation away from the mean. That's what I'm trying to find, right? So what I'll do, I'll go back to the table and I'll look for the 1.6, the probability of the 1.64. So I'll just draw, this is my normal, for example, and this is my z-score. And here probably 1.64, this is 1.64, this is my z-score. So in this question, I'm trying to find the probability of any number that is going to fall in this range, right? I'm trying to find the numbers that are going to fall in this yellow shaded region. And by looking at the table, so kindly follow like closely. By looking at the table, what can I have? The Z table, which I'll be given with. By looking at the Z table, I can have the probability of this whole part, the black part. I can find out the probability of this black because I can go back to the table, and for 1.64, right? For one point, this is my 1 point, sorry, this is 1.60001020304. So yeah, this is the value, this is the probability from the mean. So this 0.4495, this is the probability from here to here. This is the probability of this 0.4495. And I already know that the probability of this is zero point 0.5 because it's symmetrical. The right side and the area under this curve is 1, remember. And because it's a normal distribution, to the right it's zero point 0.5, to the left it's zero point 0.5 because zero point 0.5 plus zero point 0.5 equals to 1. So this needs to be zero point 0.5. So zero point 0.5 plus 0.4495 will be equals to 0.9 something, 9495. This is my area, this is all my black shaded region. And what my interest is to find the probability of this yellow shaded region. And if I just simply subtract from 1, sorry, 1 minus, because the area under the curve is 1. So 1 minus 0.9495 is going to give me the probability of any x of my returns that are going to be away, that are going to be 1.64 standard deviation away from my mean. So that's their probability. So I hope that you understand this concept. And now moving forward, look at this question. Assume the length of the this is this. So the charging of the mobile phone. So we have a battery problem here. Battery problem here. So and the standard deviation is 1.5. The mean is 10. So we have mu equals to 10. We have standard deviation 1.5. And we so now that's really important. We are trying to find the hours between 8 and 12. I'll tell you how to do it. And remember, the mean is 10, right? So the mean is 10. If you draw the normal distribution, just for the sake of understanding and to look at the table, the z table, in a right way, I'm emphasizing on this. This is really important. My mean is 10, so the 8 will be somewhere here and 12 will be somewhere here. And what I'm interested in the battery health, or whatever my parameter of interest is, to lie between this range, right? I just need to find the probability of this range. For the above question, for the above example, it was bit simple. It was bit simple, but here in this case, my I'm bounded by a range, right? What will be the way forward in this case? How can I do it? I can find the z-score first. I have two values. I have x1 equals to 8 and I have x2 equals to 12. I have two values. I can find two z-scores. So my z1 will be 8 minus 10 upon 1.5, because the formula of the z-score is x minus mu upon standard deviation. So my x is 8 for the first case, and for the second case is 12 minus 10 upon 1.5. For both cases, it's going to give you, for this case, it's going to be minus 1.33, and for this case, it's going to be 1.33, right? So what will happen? Go back to the table. Yeah, here's the table. Now you have 1.33. 1.3. Ignore this one, not this one. Here, 1.33, right? So you have this value, 0.4082. This is for the positive. But what about negative? We have 1.33 positive. We also have 1.33 negative. How can you get to know the value, the probability for the negative 1.33? It's simple, because it's a normal distribution and it's going to be symmetrical. So to the area to the right of it and the area to the left of it are going to be equal. So you can simply take the probability to the right of it, which is 0.4082, and you can multiply it by 2, because the area to the right of it and the area to the left of it are going to be equal, right? So that's why they multiplied 0.4082 by 2, and you will get the probability. So now 81.64 is the probability that your mean, your x, will be within this range, within the range of 8 and 12. And how do we know that? We knew it by calculating the z-score. We first calculated the z-score, and then we went back to the table and we come up um, with the probability, right? And similarly for this one, we have a 90 percentile. Yeah, so you're trying to find. So I think there can be a better way to solve this, because you already know that your z-score. Hmm. So you have a 90. So the question is saying, so already the format is already given, the visual is already given. So you're trying to find this area, the values in this area. Up until now, the task was to find the z-score and its corresponding probability. Up until now, the questions we have solved before was based on finding the z-score and its probability. But in this case, we are given with the probability, and we have to backtrack and find the value of x. The probability is 90th percentile, and given the information, we will try to figure out our x, and just simply use the formula, which is z equals to x minus mu upon standard deviation. And in this case, you are trying to find the x, so you just rearrange the whole equation, right? And the equation will become, you just need to plug in the values. How you're going to find no, exactly, the z-score. How would you get the z-score, by the way, in this case? How are you going to get the z-score? Hmm? You can go back to the table and you can check at the 90th percentile. 1.28. Yeah. So this one. So you can multiply it by 2 and you will get. Yeah. In this case, you have a z-score of 1.28 and you can plug it here and you will find the value of x. So that's it about. Anything else in this part? Yeah, I think it's done. So yeah, for the last question at 90th percentile, the z-score is 1.28 and you can just plug it over here. So you will find the value of the x.